Good morning and welcome again to Coffee with Mr. V. We are here again to do some more IB and A-level economics revision. And today I'm going to do cost curves, a little bit of a change. We're doing 3 sessions on macroeconomics, but we did some micro sessions before that in episodes 1 and 2 with the short run and then the long run cost curves. So now we will focus our attention onto revenue. In order to participate with Coffee with Mr. V, you need a cup of coffee or, just grab a glass, a mug, a cup of anything you want, okay? Any liquid you want. But we're going to do the synchronized sip. And now that's going to be the best part of your day. Here we go. 1, 2, 3. I love coffee. Right, let's get straight into it then. Revenue curves. Okay. This is probably the first diagram after PPFs that you drew when you learned economics, the downward sloping, the demand curve. Just as a very quick recap, the reason that the demand curve slopes downwards is not the law of demand, that as price goes down, quantity goes up. It's because of the law of diminishing marginal utility, that as we increase output, as we consume more things, the utility we get from each additional unit decreases, and therefore the price we are willing to pay goes down. Okay, this is the independent variable. This is the dependent variable. Happy with that? Right. So we've got our demand curve. We're all happy with why the demand curve slopes downwards. And what we said was, if you kind of take that box, any box underneath the demand curve, that will give you revenue. The reason it gives you revenue is because it multiplies the price by the quantity. P times Q equals total revenue. Okay, so there we go. There's our first equation. Excuse me, nearly ran out of room there. Okay, that box, that area underneath the line is total revenue, PQ. All right, a little bit of maths. Average revenue. Okay, how would you find average revenue? Well, finding average, you would need to do the total. The total, remember, is PQ divided by Q. We could cancel that down. Is just P. All right, so average revenue is just P. Well, that's quite convenient then, because the demand curve plots P against Q. So actually, it turns out that the demand curve is actually AR. Right, okay, so the demand curve is the AR curve, which now when you start thinking about your market structures diagram, basically the first thing you always need to draw with those market structures diagrams should always be the demand curve, because if you can get the demand curve, all of the other lines basically fall out of that. And then all of the points, profit maximizing point, P, where the firm would, the price that the firm would actually charge, the amount of profit that or supernormal profit that the firm might make, all comes from the demand curve. So get used to using the demand curve. Okay, so there's where our AR. Then both of the specs, both the A-level and the IB spec, say you need to know the relationships between AR, MR, and TR. Well, look, I've just given you AR. It's just the demand curve. Let's think about the relationship with TR then. This probably will work better if I draw one diagram on top of the other. So how does total revenue look or what's the relationship between total revenue and average revenue? Well, total revenue, is this quadrant here. Well, let's take a lower quantity. Let's take a quantity just here. That would be the total revenue. That rectangle looks much smaller than that rectangle. If we lower the price a little bit more, it looks slightly larger. If we were to lower it a little bit more, it might look slightly larger. Now, if you remember back to your price elasticity of demand rules, you will remember what that means about the elasticity. That when you decrease price, but revenue goes up, that must mean that you are in the elastic zone of the demand curve. Up here, remember, at the top of any demand curve is always more elastic. And that's because you're dealing with such low quantities down here that any change in quantity will be a large percentage change. PED, remember, is the percentage change in quantity, the percentage change in price. Well, even if this was just 1 going to 2, that's 100% change. So you're always going to have a very large PED coefficient coming out. So it's always going to be elastic. The rule then between P revenue when you're elastic is that when you reduce price, the revenue goes up. Since we're in the elastic zone, we reduce price, we increase output down here, and to do that we have decreased price, and therefore our total revenue is going up. When we look at total revenue down here though, look again, I've drawn that terribly, but you get the point. Again, that's a very small box. But if I increase the price here, I get a slightly larger box. And if I increase the price a bit more, I get a slightly larger box. And what's happening there is that we are in the inelastic zone of the demand curve. Because again, remember, PED changes along the demand curve. It's not the gradient. Again, many students make that error that PED is a gradient of a line. It isn't. I realize that to draw or to kind of represent PED, we kind of do, you know, this or this, depending on whether it's inelastic or elastic. But PED is not a gradient, it's percentage changes. Yeah, if we were doing the gradient, we'd be doing dy by dx, which is not what we're doing at all. When you increase price and you see an increase in revenue, that must mean you're in the inelastic zone. Okay, now what we've done here is we've gone backwards through Q, we've come left of Q, and sorry, excuse me, we've seen an increase in revenue. So that must mean that we've got that bit going on. And somewhere in the middle, there will be a peak. There will be a point where revenue, or total revenue rather, is maximized. There will be a point where total revenue is maximized. And if you can remember the rule, that is where PED would be equal to -1. And if I've drawn this accurately enough, that should all line up. Okay, total revenue then is a kind of a hill, all right? It goes up, and then it starts to go up at a decreasing rate, and then it hits a peak where the gradient is 0, okay? And then it starts to fall. And it's at that point there that PED must equal -1, because that's the rule, isn't it? That's the mathematical rule that we came up with in about week 4 economics, is to say that whenever PED equals -1, that's where total revenue is maximized. So look, there's my total revenue graph. And if you think about it, where's that? It's going to come down and it's going to cut the x-axis. Where's it going to cut the x-axis? At the same point that the AR curve cuts the x-axis. Because if your average revenue equals 0, then your total revenue must equal 0 as well. So that should all line up as well. So those two graphs are, you know, linked together in that relationship. And that is a relationship that you ought to know and be aware of going into your exam. I'm just going to move this slightly so that you can make out that PED there. I realize the light's in the way. Last one then, marginal revenue. So marginal revenue is the revenue received from each additional unit, okay? Whereas average revenue was kind of like the price per unit. Okay, and total revenue is the accumulation of all of those. Marginal revenue is the additional revenue received per unit sale, per additional unit sale. Sorry. So how do we find that? Well, first of all, I will show you a little bit of a mathematical trick, and then I will put it onto the graph where you can see it accurately. We established then that total revenue was PQ. And we also established that the demand curve was simply P. But for those of you that do kind of, well, to be honest, most of you should have covered this in GCSE maths, I'm sure, okay, but maybe more familiar to those of you who are studying maths at a higher level at the moment, all straight line graphs have a linear function y equals mx plus c, where m is the gradient and c is the y-intercept, that point there, all right? I'll just label it c very quickly there, okay? So again, I'll just say all linear functions, also all linear graphs have a linear function, like this one, y equals mx plus c. In this case, obviously, we don't have y and we don't have mx, so it's actually written out as p equals mq plus c, okay? So that's AR, remember, that's the demand curve. That's the linear function for the demand curve. Total revenue then is PQ. That's interesting. So instead of writing P though, I could substitute that in, couldn't I? So total revenue is not just PQ, it's MQ plus C. I'm substituting that in for P times Q. PQ, MQ plus C in brackets times Q, which actually comes out as MQ squared plus CQ. All right, so now we have a different formula for total revenue. Marginal revenue then is the derivative of total revenue. And again, this might be more familiar to some of you than others. But essentially, what that's saying is marginal revenue is simply the gradient of total revenue. Okay? Those of you that are familiar with it, you should be happy to differentiate that. What you come up with is 2MQ plus C. Which, if we plot that onto this curve here, and I'll do it in a different color, C is still the same, but look, the gradient is twice what it was previously. That's your marginal revenue curve. Okay, it is exactly twice the gradient of the average revenue curve or the demand curve. Starts at the same point, starts at C, finishes off cutting the x-axis at exactly, or q-axis rather, at exactly the halfway point between the origin and where AR cuts the x-axis or the q-axis. Look at it in relationship to TR. Again, what my point I was trying to make before is the MR curve is simply plotting the gradient of the TR curve. TR is increasing, so the gradient is positive, but it's increasing at a decreasing rate. So although it's positive, it's falling. Look at this. It's a positive number, but it's falling. Here we're at the peak. The gradient is 0. MR is cutting the q-axis at 0. So MR equals 0 at that point. MR equals 0 here. From that point onwards then, MR is negative. And look at this. TR starts to fall. The gradient is negative. So there you go. That is the relationship then between AR, TR, and MR. This is useful then when you're doing things like market structures diagrams, or simply when you get that question asking you the relationship between the two of them. Fine. So, as ever with Coffee with Mr. V, there is now an opportunity just to look at some of the questions that some of you were asking me about the previous episode, which was on exchange rates. So one of the questions that came in was to ask me about exchange rates during this coronavirus period and what's going to happen with them. Because I said yesterday that the pound sterling had depreciated against the dollar to a 35-year low. Well, that's true. But ultimately, all countries are kind of looking at a period of deep recession, I think, going into 2020. So although there is likely to be less capital inflow into the UK, less demand for UK exports, actually that's probably going to be the case for a lot of countries. So exchange rates, you need to think about one currency in comparison to another currency. So the value of the pound in relation to another currency. Well, if people aren't willing to, demand the pound, but they're also equally not really willing to buy the Japanese yen or something like that, then there probably will be no change between the exchange rates. So we are you can't, I guess the point I'm trying to say is that the pound wouldn't necessarily depreciate against all currencies if actually there was less business confidence around the world globally. But in the last kind of 48 hours, what we've been hearing is that, they have kind of come out of the peak in China, that factories are reopening. And so what you could imagine now is that probably quite a lot of people are starting to think about taking their money out of the UK and perhaps might putting it in those countries that are beginning to kind of start up again, opening factories back up, coming out of the lockdown process that we're only just entering in the UK now. And therefore, what you might see is a bit of an appreciation going on in those countries and a depreciation going on in the UK. Right. The other question then that I got asked was just to talk a little bit about managed exchange rates and fixed exchange rates. So that's easy. The fixed floating exchange rate system is simply demand and supply with no government or central bank intervention. And remember, we'll do this from the point of view of the pound. Okay, so this is the price of pounds, and currently we have an exchange rate of E1 set by the free market, the amount of people willing to buy pounds and the number of people willing and able to sell pounds. In the free market then, in the floating exchange rate system, this operates without any intervention from the government or the central bank. But with a fixed, let's do with a managed first, with a managed exchange rate system, the central bank is likely to intervene in order to manipulate, to influence, to affect a particular change in the exchange rate. So it might be that they want to devalue the exchange rate. We use the term devalue rather than depreciate to denote the fact that it is now caused by intervention rather than the free market. The reasons that you might devalue your currency is that it makes your exports relatively cheaper and therefore you can sell more exports. Okay, so that's what the affect that we want to get. Central banks have two main ways of doing this, although various specifications and textbooks will probably tell you that there's a few more. All right. One way is through interest rates. So in this scenario, we would decrease interest rates. If we decrease interest rates, that means non-UK residents are less willing to put their money into UK banks because the reward for saving is less. So the demand would fall and you would achieve that aim of devaluing the currency. Okay. Another one then would be to sell domestic currency. I'm kind of running out of room here with my arm. Okay, so to sell domestic currency on the foreign exchange market. In order to sell currency on the foreign exchange market, you are essentially buying foreign reserves, or you might be buying gold or something else on the Forex market. That would, in fact, that wouldn't shift the demand curve inwards, but what it would do is it would shift the supply curve to the right, because your people are, well, the central bank in this case is more willing to sell domestic currency. So that would push the supply curve out that way. And again, that would have the effect of devaluing the the exchange rate. There's a couple of other things that central bank could do. All right, those are the two main ones. The other one would be to lift any capital controls that there were on taking money overseas. So some of you probably live in countries where there are still capital controls on how much money you can take abroad through an airport, for example, or you could transfer over as a bank transfer. And I don't know what that might be. That might be, you know, back in the day, okay, in Greece, you weren't ever allowed to take more than about £5,000 worth of drachma, as it was then, out of the country at any one time. And that still might exist somewhere else. For this reason, by the way, that they didn't want lots of people taking their money out of Greece because it would devalue the exchange rate and make lead to cost push inflation in the country. So that's why they did it. So you could lift any capital controls that were in the country, and then presumably people would take their money out, capital flights, and you would get the devaluation. The other one is that you could do, you could increase the money supplies through something like quantitative easing. I'd never really liked to talk very much about that in class because, as I said in my last episode, lots of students always kind of think that this is money supply. This isn't money supply. This is the willingness and ability to sell pounds on the Forex market. However, if the central bank does print a lot of money and through asset purchasing or quantitative easing, people now have a lot of liquid cash lying about. And one of the things that they want to do with that cash is to go on holiday or buy lots of foreign imports. Then they will be selling that money on the Forex market, and that will lead to a shift in the supply curve that way. So that's the process that you need to talk about if you're going to say the money supply would also lead to that. It is true that an increase in the money supply, an increase in quantitative easing, would lead to a devaluation of the currency as well. So I've given you two main ones, and those are the ones that I would really encourage you to stick to when you're writing your exams, whether that's for the A level or the IB, but there are a further two as well. If we're to talk about an appreciation then, okay, the reason that a country might want to do that is to make the cost of imports cheaper, so particularly cost of imported raw materials or the imports of component parts or capital goods. If they wanted to make that cheaper, then you might revalue your currency. To achieve that, then you simply do the reverse of all of these. You would increase interest rates. That's therefore foreigners would want to send their money to the UK in order to achieve those greater rewards in banks. You would buy domestic currency on the forex market, and you would do that by selling your foreign reserves and your gold. And then the other two reasons, again, you could impose capital restrictions, or you could do the opposite of quantitative easing, which is called quantitative tightening, which is something that we're not going to consider right now because it would take far too long, okay? But perhaps that's something you could think about. What would the opposite of quantitative easing look like if a government or a central bank were ever to do it? Finally then, with fixed exchange rates. Fixed exchange rates is really straightforward. It's essentially a minimum price diagram and a maximum. So here's a price floor, here's a price ceiling. We're not allowing the exchange rate to go too high or too low. We're kind of keeping it in that range. And if we're keeping it really fixed, we just make that range really, really, really small until it's actually just one line. So you would draw it like that. Don't make the mistake that fixed exchange rates just exist, that a central bank can just, or a government can just say, right, we're fixing the exchange rate and it's fixed from now for forever. Doesn't really work like that. Central banks are intervening on a daily basis to make sure that the exchange rate can operate as a fix. So we're trying to achieve a target, but we're having to intervene on the market every single day to achieve that target. We're still using all of these, particularly this one, okay, in order to achieve that. So when the demand falls below that one, below that level, we would need to revalue the currency back up to the given range, back up to where we want it to be fixed. And again, like I say, we would use these policies that we'd have down here. Right, hopefully that answers all your questions. Thank you for your time, and I look forward to doing this again tomorrow, which is Sunday. Cheers. Bye.